a very warm, very good evening, right? So we're gonna start off with some simple type of Cartesian plane problems that you would get in trigonometry, but I want just us to walk through the steps on how to solve these problems. Let's say you are given sine. Let's say that you are given sine beta is equal to, or 2 sine beta equals to -1, whereby beta is an element from in fact, sorry, I wanted to say, let's make it cos. Yeah, let's make it cos. And then now beta is between 180 degrees and 360 degrees. So this is what we call the type 1 Cartesian plane type of problems in trigonometry, right? And the way to solve them is really quite simple. We must know a few tools first, right? The first tools we're gonna need in our toolbox, right? Let's have a nice toolbox here, right? So you're gonna need, number one, know your SOHCAHTOA, right? Your SOHCAHTOA. And then number two, know your cast diagram. Know your cast diagram, ne? Right? And then another thing we should, so these are the only tools that you're gonna need. And then please note, right? Please note that when you are dealing with Cartesian plane type problems, opposite, right? Opposite, opposite is y, adjacent is x, and then hypotenuse is r. Let's know these, right? One way to remember this, right, that I like, I'm sure you know the phone, I'm sure you know the name of this phone, Oppo, right? It's a very beautiful phone. I would not be discrediting it in any way, but one of the things that I just use just as a way to remind myself, right, I always ask myself this question: why would you use Oppo? So as I was saying, right, we need these tools in our toolbox, and then we need to ask ourselves, right, I ask myself, why would you use Oppo? That reminds me that y is always the opposite side. Okay, y is the opposite side, then x will be the adjacent, r will be the hypotenuse. With these three things that we have here, you should be able to master this topic. Now, what are the steps? Right? What are the steps? What must I always do when I see a problem? Say, what do I do? How do I approach it? And I say, you can answer a problem in 3 simple steps. 3. Right? Let's write it here. Let's focus on the steps. Step number 1, what do? Isolate the sine, cos, or tan ratio. But please, it must have an angle. So I'll just put brackets here to remind ourselves that you must have a certain angle inside. Ne? In fact, let's write it much beautifully, right? Let's say isolate sine bracket cos, or tan. You must isolate them. That means that number one, they must be positive, right? They must be positive. Number two, they must have a certain angle inside. Must have a certain angle inside there. Be it's beta plus 1, 2 beta plus what, as long as it's something inside and it is on the left or right hand side, you're okay. Then what is the second step? Step number 2, right, is to use the restriction, restriction to draw an arc. Now, that is step number 2. Step number 3. Use the sign of the ratio. Here we said the restriction, right? Here we are saying use the sign of the ratio. Use the sign of the ratio to draw your diagram. To draw the diagram. Obviously, here you're gonna make sure that you use the bow tie method, right? The bow tie method. Right. Once you have that, it's now a matter of doing what? It will be a matter of getting X, Y, and R. That is like the final step, right? Let's write it here. Final step is to simply get X, Y, and R, and hence solve the problems. Then you are done. These 3 essential steps are for you to draw the diagram in the correct quadrant. Then the final step is just for you to ensure that you are able to get all of your answers, X, Y, and R, and hence solve all of the problems. So yeah, good. That is all. If you're able to do this, you're okay. For the other type 2, because this is type 1, right? This is type 1. When I do type 2, I'll then indicate that it's type 2 now. Type 1, isolate the ratios, use the restriction to draw an arc, use the sign to draw the diagram, right? And then from there, get X, Y, and R and solve. Let's see how we can apply this, right? We're going to apply this on the first problem that we have there. How do we isolate the ratio on this problem? First of all, you'd make sure, since there is a 2 here, right, you need to remove that 2. And because it's attached to cos, the only way to remove it is to divide, right? So here is an example 1. Let's call this example 1, right? So you would write 2 cos beta equals to -1. And then to isolate, right? To isolate the ratio, you divide by 2 both sides, so that you have cos beta is equal to -half. Then now that you have this, right, go to your diagram. Go to the Cartesian plane, right? Go to the Cartesian plane, and then you know that usually your Cartesian plane would have 0 degrees here. This would be X, and then you have 90 degrees here. This would be Y, right? Then here you would have 180 degrees, and then here you would have 270 degrees, 360 degrees. Now guys, since your diagram is like this, the first step we said, now that you have isolated, right, let's just remember that this is the cast diagram, right? And then let's use the restriction to draw an arc. The restriction is which part? This is called your restriction there. It would be given. Sometimes they can put it like this: beta is an element from 180 degrees to 360 degrees. That's how they can also put it, right? That's a restriction. So you just start here. This is where you start, and then this is where you end. So you start on 180, right? And then you're gonna end on what? On 360, like this. This is an arc, right? Now that you have your arc, you then say, okay, done. The next step is to use the sign of the ratio, meaning you're gonna look at your ratio here, look at its sign. The sign is minus, right? Where is cos negative? But you don't look on the 4 quadrants, you only focus on the quadrants where your arc is. So between this quadrant and that quadrant, where is cos what? Negative. Then we know that it is in this quadrant. Now good people, I would like to believe that you are going to draw that arc with a pencil, and then immediately what do you do to it? You rub. Okay, you have a rubber there, you rub it. Yeah, so after rubbing it, you can now do this. So it means this would be done. You can draw the diagram using the bow tie method, meaning that this would be here in this quadrant. When I'm saying the bow tie method, I am saying that we have something like this. When you are drawing your triangles, if you want to use right angle triangles, if it is in this quadrant, it will look like this. In here to look like that. In here to look like that. In there to look like that. Right. And then now that we have this, right, you can also, if you want, indicate it as a coordinate. I usually like it as a coordinate. So now those 2 steps are done. You have used the restriction to draw an arc. You have used the sign to draw the diagram. You are now okay. The final step now is just to fill in x, y, and r. Now how will I know which one is x? How will I know which one is r? Well, the ratio says cos, and you do know that cos beta, since it's negative 1/2, cos is what? Cos, according to SOHCAHTOA, it's adjacent over hypotenuse. Now we did say that adjacent corresponds with what? X. Hypotenuse corresponds with what? With r. So that means actually you have yourself x over r. That means x is -1, r is equal to 2. So you are missing what? Y. Then how do we get y? The theorem of Pythagoras, isn't it? You do need that theorem. So you then go right and then say, okay, r squared is equal to x squared plus y squared, and then you shall indicate to the examiner that you are using Pythagoras theorem, right? And then it will be like this. Then r, right, r is 2, x is -1, and then you are looking for y. Please, you see here you're gonna have 4 minus 1 is equal to y squared. You're gonna have 3 here. Please, when you put the root, always put plus or minus. So your y should be plus or minus the root of 3. Put plus or minus for y and x, but for r, just get the positive value because r is always positive. Right, so what will assist you to choose whether it should be positive or negative? It is your diagram. Your diagram is below here, right? Of which in here y values are negative, x values are negative. So this implies that your y should be what? negative root 3. Then you can immediately say my x is negative 1, y is negative root 3, because a coordinate is always x is to y. Then r is what? R will be 2. Then you are done filling in the diagram. Then you can solve any problem that they ask you. I hope that that is clear. So it's three steps. Isolate the ratio. Use the restriction to draw an arc. Use the sign of the ratio to draw the diagram. Then simply get your x, y, and r. Let's try it on another problem. Let's say you are given root 3 sine of theta minus or let's say 2 theta is equal to negative 1. So the first thing we must do, and then they tell you that the 2 theta is an element from 90 degrees to 270 degrees. This is what they give you there. So what do? Immediately draw a diagram. By now you should know that this is 0 degrees, 90, 180, 270, 360. Now 90 to 270. Now that will mean that you use the restriction first, right? This is the restriction. So you would start from 90 here, you go to 270. That is your arc. Then you isolate. Obviously you must isolate the ratio. When you isolate it, you must have sine 2 theta equals to negative 1 over root 3. Then you look at the sign on the ratio, it's negative. Between these two, where your arc is going, where is sign negative? We can agree that sign is negative in this quadrant here. So in that case, now we can remove this. Right. Usually to even show the examiner that you know these things, do this and then you put 2 theta there. Right. And then now you just need to put in the coordinates, right? Meaning you need to find x, y, and r. How do we know which one will be x, y, and r? Remember, sine is what is opposite over hypotenuse. And we know that opposite is y. Hypotenuse is r. So this means that you are given y over r. So your y will be negative 1. Your r will be root 3. That means you are only missing your x. Then to get that x, remember, r squared is equals to x squared plus y squared. Don't forget to write there in full. Then now this is root 3 all squared. This is x squared and then negative 1 all squared. So you're gonna have 3 minus 1 is equals to x squared, and then you're gonna have 2 being equal to x squared. Root both sides. Do not forget to put plus or minus. Then you say therefore x will be looking at the diagram, these are negative x values, so therefore x will be negative root 2. Then once you have that right, then you can even put them to say this is because x is less than 0 in the third quadrant. You can explain why you chose that to be negative 2, right? Then now once you have that, your x will be negative root 2, your y will be what? Negative 1, your r will be root 3. Then you are done. You can now, no, you're not really done. You can now solve the problems. Okay, I hope that the steps are very much clear. You use the restriction, you draw an arc, right? And after that you locate, you ask yourself, using the sign of the ratio, where is it positive or negative, right? I'm leaving the questions out for now, just want us to work on that. Let's look at a past paper on this. Okay, why are we putting this arc from starting from 0 when the restriction says from 90 to 270, right? You must know that when you draw your arc, you always start from 0 and then you indicate the angle. If you draw it here, it will be like this. If you draw it here, it will be like that. You always draw it anti-clockwise until it reaches your this thing, your arc, this line you drew, and then you indicate the angle. That's why sometimes you can even be given something like this, and then something like this, whereby you have this and this, or they can give you something like this, right? So you must know that we always start from 0 there. It's like this labeling does not really follow the restriction. The restriction is only for the arc. Are we clear, ma'am?
No, sir.
What's your query?
Sir. Okay, let's do more questions and then I'll see.
Okay. Yeah, but what I'm just trying to explain is that the restriction applies to the arc, not necessarily the angle that you are given. The angle,
okay, now I get it.
Yeah, the angle would be starting from the 0 line to where you drew your diagram. But we'll see with these questions, like you're seeing. So we have the first question here from KZN. Right, so this is what we have here, right? KZN really had an interesting question, so I thought maybe we can take a look at it. It might not fit here, so allow me to do this just for a second and then go back. So now 5.3.1, right? You were given here this is what you were given there, right? And then after that you were given this as your restriction. Then they said determine what? Cos 2 beta, right? Quite interesting, quite interesting. So now how do we do it, right? For 5.3.1, do you see that it's 1 mark? It's 1 mark because this one we didn't really need to you can draw the diagram, but you don't really need to draw it as such because you can get 2 beta. So how do you get it? Remember, if you write sine squared beta minus cos squared beta is equals to 1, when you are not used to sine squared minus cos squared, we are actually used to cos squared minus sine squared. So what does this mean now? I can take cos squared to the right, it will be positive, and then sine squared would be negative, and then I still have plus 1. When I take this side, it's gonna be minus 1. Then I'm left with cos squared beta minus what? Sine squared beta, whereby this is a double angle for cos, so this is cos 2 beta, which is equal to negative 1. So that is why there it was really just 1 mark. In this question, when you have 90 to 270, this is just a range to tell you that your domain, more like a domain, but we call it a restriction because it just tells you that your angle could be between this quadrant or that quadrant. You understand me? It's just an indication to say it could be in that or in this. But then what determines where is the angle actually is the sign of the ratio. To say it's negative, then it means your angle will be in here. Then therefore, that's why 2 theta, we still draw it from the origin to where your line is. So just to summarize, this is an indication of where your angle could be, and then what determines where your angle is the sign of the ratio. And then the angle itself would be drawn from the 0 line to where your diagram is. All right, perfect. So yeah, that is just what we have there. And then now let's talk about type 2, right? Of which type 2, it's questions that will be like this. They will say maybe cos 26 degrees equals to m. Now this type of questions, right, you won't be given a restriction. Why are you not given a restriction? Because already you are given the size of the angle. You must understand that. You are already given the size of the angle, unlike the previous ones whereby you didn't know what is the angle. We are just telling you that it's between this and that, right? So here already you are given the angle, so you are not really given a restriction. That is why these problems, you treat them as if they are in the first quadrant, all of them. You treat them as if you are working in the first quadrant. If this angle is bigger than 90, you reduce it and then you work with it. For example, if I can give you cos 105 degrees is equal to m, then I'm going to ask you questions afterwards. You must reduce this one first to say it is cos 180, I think it will be minus 75 degrees. Then this should be cos 75 degrees is equals to m. Then work with this one that is less than 90. Okay, we are already giving you. So what do? First of all, make sure that it's a fraction. Again, you write it as a fraction. Then the steps to this, right, is to draw the diagram. As simple as that. Draw the diagram in the first quadrant. So you do this, and then after that you would do this. Good stuff. Then after doing that, you label to say this is 26 degrees, right? And then you make your right angle triangle there. But please, after making that right angle triangle, since this is 26, I also need you to find this one. Nay, it's very, very crucial to find it. Then after finding it, right, and then you fill your triangle, remember still, this is still x over r, because cos is adjacent over hypotenuse. So your x is m, your r would be 1. So you'll find that this one here is actually 1 minus m squared. It's the root of 1 minus m squared. Right. If it's not plus, is it plus or minus? So you'd solve it. Let me check, just so that we don't make a mistake. Let me say Pythagoras. So your r is 1, x is m, and then you're looking for y. You say 1 minus m squared would be y squared. Root both sides. In this case, you don't need to put plus or minus for this type of problems because it's always in the first quadrant. So just say your y will be the root of 1 minus m squared. Understand me? Then you would be okay. Then now you would have gotten your x, y, and r, and then you can solve the other problems. So for these type of problems, just to summarize, draw the diagram, right? Draw the diagram where? In the first quadrant. In the first quadrant. Then after drawing it in the first quadrant, indicate the given angle. Indicate the given angle and calculate the third angle. Calculate the third what? Angle. And put it there. In this case, I guess you're gonna have what? 64 degrees. I think it should be 64. 64 degrees. Calculate it. Then after that, get x, y, and r. Then you're done. So on this type of problems is quite simple as compared to the other ones. Okay, right. Let's look at some of the problems that we can get in the exam, right? All right, so let's look at this one, right, and see how we would apply that knowledge that we just learned. We're given that in this diagram we have a point x is to 24, is 25 units from the origin. T is a point on the x-axis such that TOP is theta. Do you see that? The angle is always indicated from here to where you drew the diagram. I hope you are able to see that. All right, so now if they drew it for you like this, you should rejoice. Hey, Mr. Mtavis, you should rejoice and just say x, I don't know it, but I know that y is 24, and then I know that r is 25. So to get x, what do I do? Pythagoras. Actually it's the first question. It says get x, isn't it? So you say so what would you say? R squared is equals to x squared plus y squared. Then you tell them Pythagoras theorem, and then r is what? 25, right? X is what? You don't know, but you know that your y is 24. Then you say 25 squared. 25 squared is what? 25 squared minus 24 squared should give you your x. So I don't know what you get in your calculators there for that. 25 squared minus 24 squared.
Plus minus 7.
7.
Plus minus 7.
Or you already found the roots, eh?
Yes, meneer. Therefore x equals to 7.
Okay. All right. No, that's good. Say. Thank you so much. So it means your x would be a plus or minus 7. So you get the answer to this, and then you square root both sides to get x. So, but then, right? Your x should be 7 because you are dealing with negative 7. Why? Because x is negative in the second quadrant. Okay, you are working in the second quadrant. Look at the diagram where they drew it. They drew it in the second, so we know that in the x values are negative, this side x values are positive. All right, then 6.1.2, then they say without using a calculator, determine the value of tan 360 minus theta. That would be very easy because you have your x, y, and r. So you simply say tan 360 degrees minus theta. I always say to my students, you write there which quadrant is this. Is the fourth quadrant, right? Is tan positive or negative in the fourth quadrant? Should be negative because it's only cos that is positive in the fourth quadrant using your cast diagram. Then now that you have negative tan theta, let's remember that tan, according to SOHCAHTOA, it's opposite over adjacent. And we know, why would you use oppo? It means opposite is y, and then here you have x. So I'm just writing this. You don't really need to write it. You just need to write the answer. So your y value is what? It's 24. Your x value is negative 7. Then you find that your answer is 7, 14, 21, 28. No. Just write it as 24 over 7 as your final answer. Okay. So that will be for 6.1.2 there. Quite easy. Just substitute the you're using SOHCAHTOA there. Right, and then 6.1.3, it says calculate the size of POT. Now we want to know what is the size of that theta, of that angle, right? And they didn't say without using a calculator, so we can simply use the calculator. Since we already know that tan theta is 24/7, you can use any ratio. You can use sine, tan, or cos, you still get the same angle. So remember, to get theta there, you simply say tan inverse 24/7. We usually deal with it as if we're dealing with grade 10 problems, right? Because you just need the angle. Oh, wait. You need the reference angle first again. Yeah, let's not make a mistake. This is your reference angle from general solution again. So we get our reference angle as
73.74.
right, 73.74. Even though we don't have to round it off, we're just gonna round it off for now. And then now theta, since theta is in the second quadrant, therefore you should know that theta will be 180 minus this reference angle, right? And then you should get what? 180 minus the answer, you should get 106.26 degrees. So now that tells you that that angle, you can see 106 is large, it's bigger than 90 degrees. So that is what you have there for your actual angle in that quadrant, right? Then we're gonna continue with some more problems now. Okay, so like you requested that we actually do a complete solution here. I would like to believe that for the first part it was much we did it. I can even start it again so that we don't get lost. So for 5.3.1, they are saying that they want cos 2 beta, whereas they give you that sine squared beta. Why do I like beta? Sorry, sine squared b minus cos squared b is equal to 1. So what you can do is that you can divide by -1 throughout. If you divide here by -1, by -1, by -1.
Sir,
Yeah.
sir, I
It's not the
can't
one.
see the screen.
You can't see.
The screen. There's no screen.
Guys, I can see the screen. You can't see nix. Okay, perfect. So as I was saying, right, that we can start it so that we can understand it properly, right? We can write what they gave us, that sine squared b minus the cos squared b is equal to 1. Then we divide throughout by -1, so that we have negative sine squared b plus cos squared b is equal to -1. Why? All in the name of I want to have cos squared b minus sine squared b, since that reminds me of our nice lady Vivian, cos, right? Cos 2 beta. So this would be what? Cos 2 beta. And then the answer will be -1. That will give you a 1 mark for 5.3.1. Now let's do 5.3.2. If you can remember, right, from the question that we just did right now, we managed to find the theta, but we used the calculator. Let's be honest. We used the what? A calculator, because the instruction did not say without using a calculator. But I want you to look at this one now. This one says without using a calculator. Check here. Determine without using a what? A calculator, the size of angle B. Shoo. Hey. For 2 marks without using a calculator, of which the only thing you know is this. Yeah. So what do they mean without using a calculator? Please, good people, if they say without using a calculator and you are dealing with these type of problems or on Cartesian plane, if they say specifically do not use a calculator, it means use the general solution. It means use the general solution. You understand me? If they want you to find the angle without using a calculator and you're dealing with Cartesian plane type problems, they want you to use the general solution. So that means we must solve for the general solution there. Cos 2 beta is equal to -1. So if we find the reference angle here, right, the reference angle, that reference angle would be cos inverse of 1. But that one, we, you know, if we are doing this, you are saying that I'm using a calculator. You understand me? Well, the thing is, you must know cos inverse by heart, isn't it? No, man, cos inverse of 1. That one you can know it, or maybe to simplify it, understand it this way. Let's say you have a graph for cos. You know that the graph for cos is like this, again. Yeah, whereby here it is 0, yeah, 0, and then here it's 90 degrees, here it's 180 degrees, and then here it's 270 degrees, and then here it's what? It's 360 degrees. Right, this is 1. This is -1 here. So what you just simply ask yourself, right, is that number 1, where is cos negative, right? We know that cos is negative in the second quadrant, meaning quad 2, and then we also know that it's negative in the third quadrant. This one we know, isn't it? We know from the fact that cos there is negative. Okay, so we know that we're dealing with the second quadrant and the third. But then now, in the second quadrant, remember that I'll then write 2 beta. Let me write it with yellow. 2 beta is equal to, remember the formula for this quadrant says 180 minus the reference angle plus what? 360 degrees times k. And then quadrant 3 says 2 beta is equals to 180 degrees plus the reference angle, and then plus 360 degrees times k. Right, and then now 2 beta will be equal to 180 degrees minus, what is the reference angle? Essentially, the reference angle, if you can remember, we usually used to find it by saying cos inverse of 1, isn't it? Cos inverse of 1. What you are actually saying there is that what is the x value when y is 1? When you look at the graph for cos, what is the x value when y is 1? Check. When y is 1, the x value is what? Is 0 degrees. So here you're gonna just write that your reference angle is 0 degrees. But you can even use a calculator to double check it, right? A reference angle, you see, when you are saying cos inverse half, cos sine inverse 1/3, what you are simply doing all the time there is to find the x value when y is this, the x value when y is this. So in this case, you're gonna say, what is the x value when y is 1? Well, when y is 1, the x value is 0 degrees. So that means your reference angle is 0 degrees, and then plus 360 degrees times k. Same thing here, it's gonna be 180 degrees plus 0 degrees plus 360 degrees times k. So why it's 2 marks is because the reference is because the general solution for this, when you're using minus and plus, it's the same because it's minus 0, it's plus 0, so it's just one thing. It's just 2 beta equals to 180 degrees plus 360 degrees times k. Right, then you find now the values of beta by saying what? By dividing by 2 throughout. If you do that, you'll find that your b is 90 degrees plus 180 degrees times k. Then you just simply remember k is an element of integers, right? You just let k be 0, then you find that beta is equal to 90 degrees. So that is the value of beta there. Beta is 90 degrees. Beta is 90 degrees. Beta is 90 degrees. Another way you could have solved it, right? There is another way. You could have said, you could have used the information or the knowledge from trig functions, but that one will be a bit more complex for this lesson, right? So can you design? Yes, is there a question? So for 5.3.3, let me try to remove this since we already have, but let's keep note of what is b, right? Because for the next problem we're going to need what is b. We know that b is 90 degrees. Now they say hence determine the size of angle C. Now they gave us that sign b minus c, then minus cos b minus c is equal to 0. We can rewrite this as sine b minus c is equal to cos b minus c. Right, we know that b is what? Is 90. So we can write this as sine 90 minus c, and then you will have before that, then here it's cos what? Cos 90 minus c. So this can be written as cos c is equal to sine c, isn't it? And then now remember, when we're dealing with general solutions, again I'm referring you back to that in Limpopo, this is a question paper from Limpopo, the one they wrote on trial. They do complicate stuff, that one they do complicate stuff, right? But then here, this is relating to the general solution, because now we said those problems whereby you have a sine theta plus or minus b cos theta. If you can remember this type of problems, we said we always fight to get tan. Even here we can get tan by dividing by cos both sides, isn't it? Divide by cos both sides. And that will mean that 1 is equal to tan angle C. Tan angle C. So how do you get tan angle C? Remember, reference angle, right? Reference angle. That one the reference angle there would be to say, again, should we say, okay, you can get it with a calculator. Let me just say you can just write tan inverse of 1, but essentially you can use the functions, right? But I'm saying to you can try to use even a calculator there just for the reference angle. We do know that at 90, I think tan gives us an error on 90, is it? I think tan 90 is an error. Let's check. Yeah, so in between here we have 45 degrees, and then it goes like this. Tan then goes like this, as is the original graph. It goes like this. We will do these trig functions. That's why I was saying it's a lot trig. So actually here, this 45 degrees usually should correspond to 1 tan 45. Yeah. So remember, this is to say what is x when y is 1. When y is 1, x is what? X is 45 degrees. So the reference angle is 45 degrees. Right. And then now that you have the reference angle, where is tan positive? Remember that it's positive in quadrant number 1 and then quadrant 3. Which means that we're going to say angle C will be equal to the reference angle plus 180 degrees times k. Remember, for tan we use 180. So the reference angle is 45 degrees plus 180 degrees times k. Perfect. Then in terms of the other one, we're gonna say angle C will be 180 degrees plus the reference angle, and then plus 180 degrees times k. So that means you're gonna have 180 plus the reference is gonna be 225 degrees plus 180 degrees times k. So these are the two things that you have, right? But you need to get angle C. You were given the restriction here. You were given that C should be between what? C should be between negative 180 and 90 degrees. So how do you use that restriction? After finding your general solution, that's when you go to a table. Okay, you draw your table here. Your space is gonna be a bit small. Essentially on that table you are going to be putting the values of k. I'm gonna try my best to make it visible. So this is what you would write, k, and then you write the first general solution, 45 degrees plus 180 degrees times k. Then you write 225 degrees plus 180 degrees times k. Then what you do is that this is the procedure actually that you apply to questions that are asking you about general solution. Then they give you this restriction there to find the angles. This is the method to use. So your k, you would say negative 3, negative 2. Usually I like to start from negative 3, then negative 2, negative 1, 0, 1, 2. Yeah, let's see where it gets us. Then now you will be substituting. So this is what you do. You take your calculator and then you're gonna be putting this. Usually for those ones who like playing with calculators, they know that we can put a function in the calculator. So this is what you'd put as your function. But for those who rarely do that, you can put 45 in your calculator. So you'd say 45 plus 180, and then you put negative 3. Then you get the answer. 45 plus 180, then you say negative 3. Your answer is what? Negative 495, right, degrees. Then you put negative 2, you get negative 315 degrees. Then you put negative 1, you get negative 135 degrees. Then you put 0, it's gonna be 45 degrees. Then you put 1 to be 225 degrees. Then you put 2, it's gonna be 405 degrees. Right. Then you do the same thing for 225. You say 225 degrees plus 180 degrees into k. That's why we always say k is an element of integers, because we use negative integers and positive integers to get the angles. So you say 225 plus 180 into negative 3, you get negative 315. Then you put negative 2, you get negative 135. Then you put what? 1, negative 1, you get 45 degrees. Then 0, you get 225, right? And then when you put 1 there, you should get 405. 2 there, you should get 585. So many angles, isn't it? So you go back to the restriction. The restriction says C must be between negative 180 and 90. Then you check those angles that are between that should be which ones? 45 and what? And negative 135. Those are the two angles that are between negative 180 and 90, isn't it? Yeah, so angle C could be negative 135 degrees or 45 degrees. All right, but yeah, this is just it's the general solution, good people. It's the general solution. This question is just a general solution in disguise. So you just find the general solution of this, and then from there you substitute in values of k from negative 3 to 2. Then those that are between, using the restriction, would give you the angle of C. Angle C would give you angle C. Okay, so then you'd get your 6 marks there. Right. I think then we can go to the ones we were solving again. So let's look at these ones, right? Here you are given cos 21 degrees cos to P. Determine the following in terms of P. Now what do you do? First of all, because you don't have a restriction, yes, you don't have a restriction because you're already given the angle, so you simply draw the diagram. But on your diagram, make sure the angle is in the what? In the first quadrant. Right. Make sure it's in the first quadrant. Then you can fill it in. Right. Now, cos 21 degrees is equal to P. We can rewrite it as cos 21 degrees is equal to P over 1. We need a fraction. We know that 21 degrees is here. The third angle is what? It's gonna be 69 degrees. Right, that will be the one there, 69 degrees. Then we can fill it in now. Cos is x over r. It means your x is P, your r is 1. So you're going to find that this one is the root of 1 minus p squared. Remember, we use Pythagoras again. I'm already solving for 5.1.1. This is what we do again. Let's actually take everything this side. Then here we need to find what? We need to find what we do not have. X squared plus y squared. Pythagoras. Then now r is what? R is you don't know r. Oh, r is 1. And then we said x is p. You're looking for y. So you're gonna have 1 minus p squared is equals to y squared. So your y is going to be the root of 1 minus p squared. You don't have to put plus or minus because it's these type of problems whereby you are given the angle there, they are always in the first quadrant. Now, can we then answer 5 point, okay, can we then get 10 tan 201? How do you approach these questions, right? The method that you can use is the following. First of all, start by using the reduction formula and see if you're not going to get anywhere. Tan 201, 201 is in which quadrant? That is quadrant 3, right? Because I get it, this is 0 degrees here, 90, 180. 201 is above 180, but it's less than 270. Okay, so that will mean that tan, you can reduce it, you can write it as tan into 180 plus something, because in here it's plus something. Okay, I get it in here, remember it's 180 plus theta. This one is 180 minus theta. So what must you add for you to get 201? We can add 21 degrees. So now this, remember, in this quadrant, tan is positive, so you're gonna have tan 21 degrees. And then what do you know? Since it's tan, you simply say tan is opposite over adjacent. The opposite to 21 is this one, the adjacent is this one, p. So the answer here will be the root of 1 minus p squared over p. We give you a mark for the diagram. We give you a mark for reducing, and then a mark for the final answer. Right. So that is how we would deal with it there. Then 5.1.2. Now they are looking for sine 42. The way to approach these questions, right, like I said, you start first by reduction. If an angle is larger than 90, you use the reduction formula. Just like I did here, the angle was bigger than 90. So I had to find out which quadrant is it in and use the formula in that quadrant. But if it happens that you are given an acute angle, if you are given an acute angle, there's only one thing I want you to ask yourself. Is how does that angle that I'm given, you ask yourself to say, how does it relate? How does 42 relate to these two angles in my triangle? Is it a double angle or is it a half angle of one of those? As you can see, when you say 21 degrees times 2, what do you get? You get 42. So it means it's a double angle of 21. If it's like that, do not stress yourself. Quickly write it to say sine 42 degrees can be written as sine 2 into what? Into 21. And if we can remember that sine 2 theta is 2 sine theta cos theta. In a similar way, sine 2 into 21 would be 2 sine 21 cos 21. Right? Then you know that 2 times 21 is what? Is 42. Then now you say, what is sine 21? Sine is opposite over hypotenuse, meaning is the root of 1 minus p squared over 1. Cos is what? P. So this is your answer here, 2p the root of 1 minus p squared. That is your sine 42 degrees. That's what you ask yourself. If the angle is bigger than 90, use reduction. If you are given an acute angle, you ask yourself, is it a double angle or a half angle? 5.1.3. The 151. It's an acute angle, meaning it's less than 90. Now ask yourself, is it a double angle of one of these? I don't see it as being a double angle of 21 or a double angle of 69. So it's not a double angle. If it's not a double angle, good people, immediately you invite the special angles. Immediately invite the special angles. The special angles that we have is what? 30 degrees, 45 degrees, and 60 degrees. So which one can give us 51 combined with one of these? You can say 51 minus 30. What does it give you? 21. Then you're okay. So it means I can rewrite this as what? Cos 51 degrees. I can now rewrite it as cos, and then I say, if I say 30 degrees, which is a special angle, plus 21 degrees, I get what? 51. Then, just like Mr. Liama said, you expand now. Now you're going to say this is cos 30 degrees, cos 21 degrees, minus sine 30 degrees, sine 21 degrees. Then now, cos 30, remember you have to use the triangles. I get the 1, 2, 3 triangle, 1, 2, 3, whereby 30 degrees is there, 60 degrees is here. Cos 30, it's going to be adjacent, which is root 3 over 2. Cos 21 is what? Cos 21 is P. And then sine 30, it's going to be 1 over 2. And then sine 21 degrees, it's going to be opposite over hypotenuse, the root of 1 minus P squared. Even if you don't simplify it and you leave it here, you get your full marks. I hope we understand it. That is how we deal with them. You always ask yourself, is it an angle bigger than 90? If it is, use reduction formula. If it is an angle less than 90, ask yourself whether it's a double angle. And then if it's not a double angle, you invite the special angles. That is it. Let's go to the next one. See that we're going to apply exactly the same thing. So this one here, you have tan 58. So I'm immediately going to write 5.1.1. Then I'm going to draw my... already they gave me 58 and n. There's no restriction there. So we know that we're dealing with this type of problems. So now you're going to say, this is what you have. This is what you have. And then this is what you have. And then now that is 58 degrees there. Now remember, I said you must get the other one, the third one. So you'd say 180 minus 90 minus 58, you get what? 32. So it means here you would have 32 degrees here. Perfect. Done with that. Now you just have to fill in the x, y, and r. Remember, tan 58 degrees is given as n, which can be written as n over 1. Now tan is opposite over adjacent, which means you are given y over x. So your y is n, your x is 1, your r is unknown. So you say r squared is going to be x squared plus y squared, Pythagoras. And then you say r would be the root of 1 squared plus n squared. So your r will be the root of 1 plus n squared. So here it's going to be the root of 1 plus n squared. On x you're going to have 1, on y you're going to have n. Then you can answer any question they asked. In this case, they asked you to find sine 58. So simply sine 58 degrees. Remember, sine is opposite of hypotenuse. So the opposite is going to be n. This is n here. Ne? It's not that beautiful. So you say n over the root of 1 plus n squared. Then you are done. Then you go to 5.1.2. You have sine 296. It's bigger than 90, right? Then we have to reduce it first. So you'd say sine, it's in the third quadrant, so you're gonna say 180 degrees plus. How much must I add to get, wait, it's even bigger than 270. And here you have 0, 90, 180, 270, 360. So 296 is even bigger than 270, so it's in the fourth quadrant. So you say sine 360 degrees. How much must you subtract to get 296? You must subtract 64 degrees. Perfect. Then now you know that in this quadrant sine is negative, so you're going to have negative 64 degrees. Then 64 degrees, how does it relate to 58 and 32? It's not greater than 90. Is it a double angle? Yes, it is, because 32 times 2 is 64. So you say, oh, okay, this means I can write this thing as 2 into 32 degrees. And if I write it like that, it means I'm gonna have 2 sine 32 degrees times cos 32 degrees. Now you can work with that angle now. 32 sine 32 is simply opposite over hypotenuse, which is 1 over the root of 1 plus n squared. And then cos 32 is going to be adjacent, which is this over 1 plus n squared. So this will mean that you have negative 2n over 1 plus n squared. And you are done. Quite simple. And then 5.1.3, the one cos 2 degrees. Who can assist us with that one, guys, before we go? Yes, that is true. So we're going to use special angles, because 2 degrees is not a double angle of any of these, so we have to invite the special angles. And when we invite 30, 60 and 90, you can see that if you say 60 minus 58, what will you get? You will get 2 degrees. So it means that you can say there cos 60 degrees minus what? Minus 58 degrees will give you 2 degrees. And then you can expand, just like Mr. Liama said. Cos 60 degrees, cos 58, then you say plus sine 60 degrees, sine 58. And then from there, cos 60, you know that it's going to, using the special angles, let me just use this one. 60 cos is half, it's going to be half. And then cos 58 is going to be adjacent over that, it's going to be 1 over the root of 1 plus n squared. And then sine 60 would be the root of 3 over 2, and then you will have sine 58 is going to be n over the root of 1 plus n squared. Then you're good. The rest is just to simplify. The final answer, if you simplify, it will be 1 plus the root of 3n all over 2 the root of 1 plus, no, it's like 2 into, I can always say, yeah, 2 root 1 plus n squared, because denominators are going to be the same there. Okay, so but then that is how you deal with them, guys. I hope this was very helpful. Please just remember, I'm gonna go to the first slide, and then just remember that when you're dealing with these, isolate the ratio, use the restriction to draw your arc, use the sign to draw the diagram, get x, y, and r. And then don't forget that x, y, and r relate to opposite, adjacent, hypotenuse, so we must remember SOHCAHTOA. And then let's remember that for general solution, right, we need to know how to apply it. So revise that, and then for these ones, they're not difficult. You just draw the diagram in the first quadrant, you indicate the given angles and calculate the third one if it's not there, and then yeah, but it won't be there, and then you get x, y, and r, then you're okay. All right, any question?